student mode, right? No, we don't. Example number 4 says graph trigonometric functions. So we're going to graph trig functions. Okay, so it says determine the period, the domain, the range, and draw the graph of the function. So we're told to graph y equals 3 cosine 2x 2x minus pi plus 1. Okay? So we need to graph this. So what I'm going to do is, this is a transformation. So this is my x and this is my y value. When I graph cosine, does anybody remember what the graph of cosine looks like? Looks like this, right? It goes like this. It goes, and then it goes, okay? All right, so now what is that? What are these things? Well, this right here is 1, and this right here is negative 1. And from peak to peak, the period of this is, oops, I misspelled period, is 2 pi. Okay, so from here to here, it's 2 pi. So this is, I guess we would say, y is equal to cosine of x. So we need to unpack what this stuff, the information they give us here. 3 represents what? Does anybody remember?
No.
Amplitude. So what we're gonna do essentially is we're going to graph the same function, but instead of it going from 1 to 1, we would need to make it go from 3 to negative 3, because that's the amplitude. All right, but don't start graphing yet, because we got to do some other things too. And so this is written really in the form of y equals a times f of b of x plus c plus d. And so a is really, a is our amplitude. Another way that you could think of this is you could think of it like f of x is equal to capital A, which is the amplitude, right? Sine or cosine, it doesn't matter. You can put them in either way. So I'm just going to write down sine so that you know that it applies to both. Because the period is 2 pi, we would say 2 pi over b plus or times x minus c plus d. All right. So now here's a couple of things. The b term, this b term, we have to derive that, but the b term represents like a shrinking, like a horizontal shrinking or stretching. So this is like a horizontal stretch. It's like a shrink or a stretch, depending on what it is. Oops, forgot a T. And or shrink. The C term is a horizontal shift. So it'll move it left or right. And then D is what we call a vertical shift. Okay? So we've got a lot of stuff in here to work with. So the first thing that I need to do is, the only problem is I know that 3 is the amplitude, okay? And I know that 1 is the vertical shift, which means we're just going to take this whole function and shift it up 1, okay? 1 unit. The problem is inside the parentheses. I need to make this look like this. So what that means is I'm going to have to factor out this 2 away from the x. Okay? So that's not, I want a number in front of, I guess what I'm trying to say is I want a number in front, I need a scalar, x needs to have a coefficient of 1, not 2. And so what I could do is I could rewrite this as y equals 3 cosine of something times x minus something plus 1. So what do I do to get 2 by itself? Like, how do I make that 2 become 1? Yeah, so what I got to do is I'm really dividing by 2, right? So I'm factoring out a 2. The issue is that this top line has to equal the second line. So what do I put in here? What do I, in other words, what do I multiply by 2 to get pi?
So,
Pi over 2. So these are equivalent statements, but this is written in a form where I could kind of use a shortcut here. Okay? Now with that being said, I know that the amplitude is still going to be 3. Right? This is still the amplitude. This is still the vertical shift. But now I have the shrinking with regards to the period. It's 2 pi divided by b should equal 2. And then c is my horizontal shift. Okay? So how do I, what would that look like graphically? Well, since we're shifting it up 1, instead of this being symmetrical about the x-axis, and it kind of is sort of, it's going to be symmetrical about plus 1. And so then I'm going to have to go up 3, so I'm going to go 1, 2, 3, and then I'm going to have to go down 1, 2, 3. So that's kind of where my waves are going to fit. So I'm going to draw like a dotted line. This is how you transform trig functions by hand. Now, truthfully, on the AP Calculus exam, you'll probably just do it on your calculator, but it is so helpful to kind of know how to do it by hand. And you can't really see. Let me change the color of that. So, can you guys see that better? So my cosine function is going to have to start here. Okay? So now, how do I graph that thing? Well, the first thing that I need to do is this 2, I need to deal with this. I know that this 2 has to equal 2 pi over b, because b is really the period. So what I'm going to do is over here on the side, I'm going to say 2 is equal to 2 pi over b. Cross multiply, I get 2b is equal to 2 pi. Divide both sides by 2, and I get b is equal to pi. So that means my period now, instead of normally it would be 2 pi, my period is pi. So I need to complete one cycle of the graph in pi units, 3.14 as opposed to 6.28. And then C is the horizontal shift. Well, that's easy. The horizontal shift then is going to be negative 2 pi. So normally, I'm going to start right here on the y-axis, but my horizontal shift, is that to the left or to the right? Well, technically the C term is positive, so I would move to the right. So normally I would start a dot right here, but I'm going to go over pi over 2. So this is where my cosine starts. Okay? Now, how far do I go over until it starts again? Exactly 1 pi, because my period is pi. So over here at negative pi over 2, I should have another peak. And then if I go, this would be pi, and if I come over here, this would be 3 pi over 2. But isn't 3 pi over 2, isn't that the length of one period, which is pi? And I suppose if I come negative 3 pi over 2, here. So now I'm ready to graph this thing. okay, by hand. And so what this should look like by hand, and let me choose a different color so you guys can see it, is that by hand, I need to come, if I come from here, I need to come down and go right back up. And so right in the middle of these two is where my trough should be. So I'm going to come down and be right back up here. And again, in the middle of these two, I need to be way down here. So I'm going to come down. And right in the middle of these two, I need to go up and down. And that's what it should look like, roughly, right? So Mr. Adams has sketched that roughly by hand. So now how can we verify that? Graph it with the calculator. So now if I come in here and I open up the calculator and I graph what was the function? 3, and we'll want to graph the original function, right? So we'll want to say, like, we want to graph this thing. So I'm going to say, let me move this over here so we can see it a little better. I think it's 3 cosine 2x minus pi plus 1. And then I'm going to hit zoom trig function. That might not, that might work, it might not work. Let's see. That looks pretty good, doesn't it? Now, it's not enough just to draw the picture. We've got to verify the results. So what is this value right here? Well, y equals 0, but what, not y equals 0, x equals 0, but what should my y value be? -2. So if I plug in x equals 0, it should be -2. Is it? Yup. What should my y value be when I'm at pi over 2? So if I enter in second pi divided by 2, I should be at y equals 4, right? Because that's kind of how I sketched this thing. So let's see. Yep. Do you guys have any questions?
Where'd you get the 4 from?
Well, the vertical shift was 1. So normally normally my cosine function looks like this.
And that's 3 to 3?
Yeah, but what it does is it's symmetrical about the x-axis, and it's 1 to -1. So the symmetry has now been shifted up 1 whole unit because my vertical shift is 1. So instead of me being down here, I had to shift that. I had to shift the symmetry, or the center of the graph, to y equals 1. I had to shift it up 1 because this is plus 1. But now my amplitude is 3. So from here I had to go up 1, 2, 3, and then I had to go down 1, 2, 3.
Okay.
And then I put these other orange, and that helped me frame where cosine had to be. And then we had to do the same thing. I had to find the period, but where do I start is based on the horizontal shift. So normally we would start cosine right here on the y-axis, but the horizontal shift was pi over 2. So I had to take this point and shift it over pi over 2. This will be kind of hard for you guys.
Yeah.
So what could you do to kind of help you along? Graph it on your calculator and double check the values on the calculator, right? And then sit there and just try to think, well, because the algebra behind this is easy, right? You guys can set this equal to whatever this number is. I have every confidence in you in that. But trying to understand how to graph it by hand will be different. It'll be hard. But you guys can do it.